Hello dear friends, this is Paul, Oscar Mike Zero Echo Tango, and I'm very happy to show you today something new, what I found on the AliExpress. It is a small or ultra small SWR and power meter, which is great for the QRP application or even for the QRO applications. This power meter for 120 watts is for 46 euros right now on the AliExpress, and the link you can find down in the video description. So let me show you more about this thing. Let me open the box for you, break these little seals, and we'll show you how it looks also inside. Let's measure this thing and we'll see if this little equipment really works as should be. So let's get started. Alright, so firstly let me say something briefly around this little device. So the dimensions of this SWR power meter are pretty small because this little device, as you can see, fits into my palm, and the dimensions of the box is 38 millimeter high and 88 millimeter wide, and depth of this little device is 63 millimeter only. This little SWR power meter is a portable power meter and has an internal 1 amp hour battery. So here you can switch this little thing and you can see that the version, the frequency range, and then you can see the screen with these all values. Here on top is the forwarded power, so it is the power out from your transceiver. It's the reflected power here, and so is the power which is returning back into your transceiver from your antenna or coaxial feed line. And then here is the SWR value, and this is the value what we want to measure, and the best value if you measure your antenna is as low as possible, so maybe 1.0 is ideal. Then on the bottom here on the screen is the battery voltage, so I can see that the battery is almost fully charged. Full charged is, I think, 4.1 volts. Alright, so here on the right side you can see 3 LEDs. It's orange, green and red. So red is by charging, full is when your battery is fully charged, and this is lighting, as you can see now when the power button is turned on. Here on this, in this corner, you can see this little small hole, and it's the audio signalization or indication when are you measuring a very high SWR or poor antenna. And this may prevent damaging of your output power amplifier or the power output stage of your transceiver, which is really a good thing. As you can see that the maximum peak power of this little device is 120 watts. And for more info, you can read down in the video description in the link where is this little device described. Alright, so here on the back side of this SWR power meter, you can see two SO239 sockets with goldened internal pins, which is good, and you can see that capability of this little device is the FM, AM modulation and SSB as well. Alright, so connection to this little meter is TX this is the cable to your transceiver. So you have to need a short piece of cable PL259 to PL259. And here on this side, you can directly connect your antenna connector. The case is made of the aluminum, so it is completely metallic case. The main thing to measure and test the SWR meter is to have a 25 watt dummy load, or you can use any other ones for 100 watt or 150 or even more. I have this little 25 watt dummy load, mainly used for my QRP applications. It is a cheap dummy load. I bought it for about 15 euros. 15 euros with shipping, so it may be a little bit more, maybe 20 or 30 euros. And I have the dummy load with the N socket female here on top, so I had to use reductions because I did not have such kind of cable. So the other thing is my Mini 1300 antenna analyzer, which you had seen many times in my previous videos, and of course the Xiegu X6100 transceiver, QRP transceiver for 5 watts, and it can be used also 10 watts with an external power supply. And here I can use also some other reductions and jumper cables to connect my SWR meter. All right, so firstly, let me check the SWR of this little dummy load. So connect the dummy load to my Mini 1300 antenna analyzer, and let's test this dummy load first. So the frequency sweep, and I switched into the wideband mode right now. It's from 1.8 megahertz to 1000 megahertz, so it is pretty wide right now. And let's check the dummy load. Well, so this is these values of the SWR. Let me focus on it. So here you can see that this is somewhere here, the short wave, and this is the VHF, this is the UHF, and up. So it's not so bad at all. You can see that the short waves are nicely in the range of 1.1 SWR. You can see. And the VHF, there are strange peaks. I don't know why. Maybe that's something about this many reductions in the line. I don't know, maybe. But of course, I'm interested in the short waves, and it looks pretty well. I can change to the short wave frequency range, let's say 160 to 100 megahertz, and scan. So you can see the screen from 1.8 to 100 megahertz. And you can see that the flatness of this dummy load, it looks pretty well. And you can see short waves somewhere here, and 6 meters somewhere here. So it is pretty flat. 1.1, no, 1.0 is the minimum SWR measured. All right, so this little dummy load is ready to go. And now I will connect this thing to the SWR meter and my Xiegu X6100. Remove the protective caps from the SO239s on the back, and then here to antenna connector, connect the dummy load or your antenna. As you can see, I'm using many reductions between the dummy load and my SWR meter, but in this case is the best scenario because I don't have any better reduction between the N connector and the PL connector. Of course you can use it, but I don't have it. Here is the cable from my transceiver. There is also connection reduction between BNC and PL259, and I'm connecting it to the TX socket here on the back. So I'm prepared for test, so just turn on the rig. And as maybe you noticed, I am on 20 meters right now, somewhere in the middle. 20 meters is most used band on the ham radio in shortwave, so I'm using it for the first test. So I have AM modulation, turn it on, as you can see here on this picture. So it's the carrier mode, best for measurement of your antenna or dummy load. So I'm going to push the PTT button here, and you will see the power here on the screen. You can see the 5 watts, and you can see here also 5 watts, 5.03. I'm talking, so the power is a little bit unstable in AM mode. There is the reflected power is 0.0, which means that there is no any reflected power from your antenna because the SWR value is 1.0, which is ideal, and that means that no reflected power is present. Again and again. All right. So now I will measure the SWR on the other bands and the power as well. So I'm going down to 1.8, and I'm ready to measure the power on all bands. So 160 meter, 5 watts also. 80 meter, 5 watt, SWR 1.0. This is 5.4 megahertz, 60 meter, 5.03, almost 5 watts, the same, 40 meters. Yeah, you can see that the output power on this band is not 5 watts. It's only 3.5 or 3.46 watts. 30 meters, 5.303. 20, 5.03. 17, 4.78, 15 meters, 4.9, almost 5, 12 meters, only 3 watts on 12 meters, and 10 meters only for 3.6 watts. And finally, I will find the 6 meter band, 51 megahertz, only 1.55 watts. But you can see that the SWR is blinking. There is SWR between 1.0, 1.11, which is a little bit higher than on the short waves, but it is normal. It is still almost ideal. All right, now the real test with the real antenna connected to the SWR meter directly. So the magnetic loop is indoors. SWR was the best, I think, about 1.3. We can check on 40 meters. Yeah, 1.4 is the SWR here on the antenna indoors. So I am here on 40 meter band and I have a 10 watts because the radio is connected to the power source. So 10 watts, and let's check the forwarded power here on top and the SWR on the third line. 10 watts, and go down to 9 watts, 8 watts, 7, 6, 5, 4. It's pretty accurate. 3 watts, 2 watts, 1 watt, and 0.9 watts, 0.8, still pretty good, 0.7, 0.6, half watt, 0.5, 0.4, 0.3, 0.2. Perfect. And the minimum 0.1. There is not a big change. All right, so it's really accurate, and now I will increase the SWR. I would like to start a buzzing. Okay, so I go up with the SWR. I will detune the antenna, and I found that if the SWR increase over the SWR2 in the third line, this device will start buzzing. You see that it's buzzing, and SWR is actually right now 13. It's pretty high right now. So that's the danger for your output components in your transceiver. So therefore is this thing little here on the corner very good helper. So now let me open this SWR power meter. I have to break the warranty labels here on the side. So please don't do that, because you will lose the warranty. And by the way, you can see here on the label, maybe it is the designer of the SWR meter, Bravo Golf 5 Charlie Quebec Victor. Maybe this Chinese guy is the manufacturer as well, I don't know. There are used the Phillips screws, and you have to unscrew only the upper screws from the box or enclosure. So here and also here and here. No need to unscrew the other ones. All right. So now we have to open the upper side of the enclosure. Okay. And here are the components. I see that all these modules are connected via the connectors, which is great. I will disconnect the battery to be sure that there will be not any short. All right, so here you can see the internal battery. It is 1000 milliamp hour battery, 3.7 volts. And you can see that the model is 503450 with connector. And here inside, there is the connector with the cable to the switch, to the power switch. You can see the all LED display module. And this display or the screen module is glued by the silicone or something to the front panel. And let's look closer inside to the box. So here we have the SWR and power meter transformer. We have the primary and secondary windings and connectors connected to the center pin, here to this little transformer. Here we have the measurement resistors, and here is probably the CPU or processor. Here we have a U3 circuit, and as you can see that it is Tango Charlie 405 and so on. I don't see much, but I'm not able to read the model of this processor. Manufacturer scratched the surface, so you're not able to see what is inside. As you can see that the designer of the PCB board is the Bravo Golf 5 Charlie Quebec Victor. Okay, so it's really nice looking piece of device. You can see closer these all components. I guess that the Q1 is the stabilizer or something, or just the switch. Yeah, maybe it is the switch or the switching transistor. All right. So this is the small Chinese SWR power meter device. And for the final, maybe I will say that I'm very, very happy with this little power meter. I finally have one digital power meter for precise reading. If you are interested in some devices used in this video, you can see the links, or you can find the links down in the video description. I will be very happy if you hit the subscribe button, if you hit the like button, and if you will join again in the next videos. Thank you very much for watching, for your time, and looking forward to see you in the next ones. 73 guys, bye-bye, good luck.